Hello, this is Bill Kiker, Kilo Charlie 1 Hotel Tango Tango, and today instead of talking about ham radio, I'm going to talk about my car, a 2024 Tesla Model 3 all-wheel drive. And I'm going to show you how it does full self-driving, although supervised, under version 12.3.6. So before I show you that, I want to tell you a little bit about the car so you understand what kind of sensors it has and the computing power it has. So the sensors are known as Tesla Vision. The only thing this car uses to navigate and to drive is basically 7 cameras, 2 high-resolution cameras, about 5.4 megapixel, looking out to the front, 1 rear camera, and 4 side cameras of lesser resolution. All the cameras are running at 24 frames per second, so this is the data that the car uses to basically decide how to drive. In addition, it has a GPS receiver, so it knows the route. This is a view of the hardware, a simple view of the hardware. It utilizes 20 CPU cores in the full self-driving hardware 4. Running at 2.35 gigahertz. In addition, it has 3 neural network processors running at 2.2 gigahertz. If you want to find out more about this particular hardware 4 implementation, how it compares to hardware 3, you can follow the URL that's listed at the bottom of this slide on YouTube. This is a view of the notes that are used, the release notes for the software that's being employed in this test. FSD 12.3.6. And you can see that this particular software differs from earlier versions because it's been trained on neural nets on millions of video clips at Tesla. So the software has been developed that way. And it utilizes human supervision. That is, you have to be able to take control of the car in a dangerous situation. Otherwise, it will make lane changes, select forks to follow your navigation route, navigate around other vehicles and objects, and make left and right turns and obey the traffic laws in the area. But once again, you are authorized to use this, but you have to remain cautious and attentive. It is not an autonomous vehicle yet, so you can't become complacent. In order to enable this, you press the right scroll wheel button once. You can disable it by pressing the button again or tapping on the brakes or steering manually. When it's enabled, you see a blue vector that extends out in front of the car, forward of the car. And you can see on the display, similar displays on the car, when it's driving like this, you can see traffic lights and they're indicated red or green. You can see pedestrians, other cars, parked cars, cars entering an intersection. And the car makes decisions on how to drive based on that information. So once again, here's a photo of my car. I call her Scarlet Kilowatt, and it's a long-range electric vehicle, delivered on the 29th of March 2024. So in order to do the test drive, I'm going to describe the conditions that were present whenever I did the test drive so you can understand how it's working. So once again, it's version 12.3.6, and the hardware 4 is implemented with 7 video cameras, and the software is real-time Linux OS derivative, and then on top of that, the self-driving software. So this was done on Friday, May 17th this year. The weather was clear, few clouds, it was warm, bright, and a dry day. The terrain was hilly, rural, suburban, in southeastern Connecticut, and the destination that I input to the GPS was the Knights of Columbus Hall in Mystic, Connecticut. And during the trip, it encountered two-way traffic on undivided 2- and 4-lane highways and town roads at a variety of speed limits, all less than 50 miles per hour, stop signs, and traffic lights. So the route that was taken is shown in the next slide here. This is a plot using Google Maps, and you can see it's 13-minute drive, roughly 7.4 miles, starting on Connecticut Route 234, turning left onto Anguilla, South Anguilla, and then left again onto on US Route 1 into Mystic, and then turning right on Hatch Street to the Knights of Columbus. So the video is about 14 minutes, and I'm going to show you the uninterrupted version with some comments as we go along. So here I am. I'm setting the destination. I'm going to select the Knights of Columbus in Mystic, Connecticut.
Now turn right onto Pequot Trail.
And the GPS indicates it's a right-hand turn. I will then initiate FSD by pushing the button on the steering wheel. You'll see that in a moment. Okay, ready to go. And there, we're off. Now the car is steering itself onto Connecticut 234, headed generally west. Unfortunately, the rear view mirror is blocking part of the view of the highway. And by the way, the rear view mirror has a camera, a cabin camera, that's looking at me to see if I'm paying attention to the drive, that I'm not sleeping, not playing some video game or on the phone. I'm attentive to the drive. In addition, I have my hands on the steering wheel. I'm not steering. I'm just presenting a slight amount of pressure on that steering wheel to indicate again to the car that I am participating in the drive as a supervisor. The car, however, is making decisions on the speed, and you can see here the speed is roughly 40 miles per hour. That's the speed limit in this section of the road. And we'll be approaching South Anguilla on the left.
In 1,000 feet, turn left onto South Anguilla Road.
You'll hear the turn signal.
Now turn left onto South Anguilla Road.
See, my hands are off while it's turning. You can leave your hands off of the steering wheel momentarily. You don't have to hold them there all the time. But I'm being extra cautious. Now this is a narrow point in this road, a very narrow point where the bridge is. It's only 2 lanes, undivided, no passing allowed in this road. And it's moving along at about 30 miles an hour, which is slower than the limit on that road, which is 35. Once again, you can see the blue vector here indicating FSD. It doesn't sense potholes or depressions in the road, so it has to run over them. There's a Jeep off to the left, and a car that's backing up while it's partially on the road. The car is moving slowly, down about 26 miles per hour. Now that it's past that obstacle, it will increase to about 30 miles an hour. See, it's encountering cars moving in the other direction, opposite to the route that we're taking. The car is in control. The water on the road is associated with the heavy rains that preceded this trip several days earlier, and that's just drainage. The car cabin is fairly quiet. Electric vehicles are like that. This particular car has a lot of sound insulation, and you don't hear any rattles. The fit and finish is very good. We're going downhill, and the car is converting the potential energy into kinetic energy into electrical energy. The motors are now generators. And the electrical energy is being stored as chemical energy in the
In
lithium-ion
1,000
batteries.
feet, turn right onto South Broad Street.
We're going to make a right-hand turn into Route 1, U.S. Route 1, headed south towards Mystic, Connecticut.
Now turn right onto South Broad Street.
Note the stop sign. The car is stopping on its own, and it's evaluating traffic to determine when it can move into traffic on Route 1. It's accelerating now. And a traffic light is coming up. And the cars in front are slowing down. And one will be turning left. So now the cars are accelerating, and the Tesla Model 3 is accelerating up to 35 miles per hour. You can see the blue vector again, and we're right about here. The car automatically slows down when the car in front slows down. And it's traveling again on an undivided two-lane highway at 35 miles an hour, following the traffic speed limits. The speed limit changes on this highway. We're now moving at 40 miles an hour. You won't get a speeding ticket when the Tesla is driving. It follows rules precisely, unless you have put in a bias to have a higher velocity than the speed limit. So now it's moving at 45, which is the current speed limit on the road, US 1. Another intersection there. Hands off. The car is driving itself under my supervision. Really have to trust this car that it's going to make the right decisions and drive safely, and it appears to be doing that. Another traffic light, and the car is stopped at the intersection. You can see the intersection here. Now it's accelerating. Electric vehicles have great acceleration. It's moving up to 50 miles an hour, which is the speed limit in this section of the road. As long as this blue vector is present, the car is driving under full self-driving conditions without my help. Another intersection controlled by a traffic light that was green. into a section where there are 4 lanes on Route 1 headed south. The lane on the right is only for the convenience of people making right turns. Going 50 miles an hour, you can see the traffic arrows have converted it back to a 2-lane highway from 4 lanes on our side, but still traveling at roughly 50 miles an hour. You'll see the speed limit change. It will be reduced to 45 miles an hour. The car will precisely make that change at the appropriate time. There, it slowed a bit because of the bicyclist. Now it's at 45.
1 mile, turn right onto Hatch Street.
About 1 mile from the destination. Again, GPS is telling the car which way to go. And the car is making decisions based on local traffic laws and traffic conditions. Now it's slowed down to 40 miles an hour as we're approaching Mystic, a more heavily populated area. And there's a traffic light, and cars are entering on right turn on red. And the car is traveling at 35 miles an hour now. That's the speed limit here. You can see the sign. And it's approaching another traffic light at the top of a hill. Slow down for the car making a right turn. And now it's climbing a hill. Traffic lights at the top of the hill. Slowing down. Going down to the hill. We're almost at our destination. We'll be making a right turn on Hatch Street coming up.
Now turn right onto Hatch Street.
Notice how we're turning, and there's a big pickup truck there. We don't want to hit it. The car avoids that and gets back into the unmarked town road with
In
a stop
500
sign.
feet, your destination will be on the left.
And a short distance to the final destination on the left.
Now your destination is on the left.
Okay, now to summarize. What you just witnessed was a fully automatic Tesla Model 3 driving under FSD for 7.4 miles for about 14 minutes. You saw that it encountered two-way traffic on undivided 2- and 4-lane highways and residential roads under a variety of speed limits, stop signs, and traffic lights. It executed right and left-hand turns to enter traffic, stopped at all stop signs and traffic lights, obeyed all posted speed limits, navigated around cars and other objects. Just what the software release notes stated. But once again, it's FSD 12.3.6 supervision, and it requires frequent driver contact with the steering wheel, while a cabin video camera is monitoring your state of awareness and alertness. So the driver must always be alert to traffic conditions, unusual traffic control situations, including partially obscured vehicles, partially obscured obstacles, and traffic control signs and lights, and always be ready to disable FSD and take control of the automobile. So I consider that this full self-driving test using Tesla Vision and FSD 12.3.6 with supervision was successful. No human intervention was required during the entire drive. I think that's something. So this is Kilo Charlie 1 Hotel Tango Tango 73 and signing off.